Okay, so we'll talk about matrix addition, matrix multiplication, and have to find the transpose of a matrix and the trace of a matrix using Python. So first we'll discuss matrix addition. So we know what a matrix is. A matrix consists is an a matrix is an array of numbers. It has rows and columns. So here we have two matrices, A and B. And A is a square matrix which has two rows and two columns. So P is equal to 2 and Q is equal to 2. And for the matrix B, it's also a square matrix consists of four elements, which is of two rows and two columns. So when we add these two matrices, we see that it is an element-wise operation. So the first element of the matrix A is added to this first element of the matrix B. So the first element of matrix A is 1, and the first element of matrix B is 4. So when we add that, we get 5. And similarly, all the elements are added in this manner. So the second element of A gets added to the second element of B, and vice versa. And here we get the result A plus B is equal to 5, 4, 7, 4, which is the addition of the element wise, which is an element wise addition of these given matrices. So now we move on to the program. Okay, so here is the program. So first we have to input the number of rows. Okay, so first we'll type row is equal to int input, enter the row number, and that which is specified in the inverted commas will be entered in the output. So int means the integer. So here we input the row number, and the second we input the column number. Column is equal to int input and the column number, and then we enter the elements of the matrix. So first we'll print enter the elements for the matrix 1. So so that will be displayed in the output, and then we define matrix 1 as int input for I in range column and for j in range row. So here we use a nested list method in which the values of the elements are entered. So for the first, we have int input for I in range column. So first we write the column, the elements for the column, and then we write for the rows. So after the elements are entered, then we have to print these elements in a matrix form. So then first we type print matrix 1 in inverted commas, and then we'll see in the output as matrix 1, and then we create two for loops for row and column. So for the first for loop, we have for I in range row, and for the second we have for j in range column. That means these I and j's will get incremented in this row and column numbers which we have specified in the beginning. So, and then we type print format matrix ij less than 3, and we have an empty string. So the format is to leave equal spaces between the elements, and the end is equal to is to have the control over the same line and not to and it's because we don't want the numbers uh, to be printed on the next line. We want all the numbers to be printed on the same line when we type row and the columns, and then we print. Similarly, for the second matrix, we type print enter the matrix enter the elements for matrix 2, and then we type matrix 2 is equal to int input for I in range column and for j in range row, which is similar to the first. So int is for integers, and then in this step we enter all the elements which is to be placed as rows and columns, and then for I in range row, for j in range column, we make this list which we have entered into a matrix format, and then we print it. And next we have to find the result. Okay, so for result is equal to first we give an empty list which is 0 first, in which all the elements are zeros, and then we input the sum of the first and the second matrix. So input for I in range column and for j in range row, and for I in range we have row, the range is row, and for j in range is column, and then the result ij is equal to matrix 1 ij plus matrix 2 ij. So here in the first, when it is 0, the I and j is 0. That means it is the first element of the matrix 1, and similarly for the matrix 2 also it is the first element, and then this will get added and stored in the result which we have given here. And then we type for I in range row and j in range column, print result ij less than 3 end string, and we print. So here the result will be printed as the addition of these two matrices which we have supplied. Okay, so this is about the matrix addition. And for the matrix multiplication, okay, so the matrix multiplication has a few conditions such that the number of columns of the second the number of columns of the first matrix must be equal to the number of rows of the second matrix. So here we have a matrix A, which is of 2 rows and 3 columns, which is a 2 by 3 matrix, and we have matrix B as 3 rows and 4 columns, which is a 3 by 4 matrix. So we have number of columns of the first matrix is equal to the number of rows of the second matrix. P bar n is equal to n bar q, where n is the same for A and B. Okay, for A, n is the number of columns, and for B, n is the number of rows. Okay, so when we multiply it, it goes like this. The rows, the elements of the rows of the first matrix is multiplied to the elements of the columns of the the second matrix, and it is given here. So here we have the first matrix. We have 1, 2, 3 as the elements of the first row, and we have 1, 5, 9 as the elements of the first column of the second matrix. So multiplying this, we will get 1 into 1 plus 2 into 5 plus 3 into 9, which is equal to 38, which is the first element of the resultant matrix. Similarly, in the second element is given by the first row of the first matrix multiplied by the each element is multiplied by the second column of the second matrix, which gives us the second element of the resultant matrix. And for the third, we have the first row of the first matrix, the elements of the first row of the first matrix, which is multiplied by the third column of the second matrix, which gives us 50. And for the second row first element of the resultant matrix, we have the second row of the matrix A multiplied by the first column of the matrix B. So in this wise, we have the resultant matrix. So to look at the problems, to look at the program, we have, okay, so first we type in the row of the number of rows of the first matrix, and then we type in the number of column of the second matrix, because the number of column of the first matrix and the number of rows of the second matrix is equal, which is given by n. So p by n is the format of the first matrix, and n by q is the format of the second matrix. So we type in that, then we type print the elements for matrix 1. Now we are entering the elements for the matrix 1, which is in a similar fashion which we have done in the previous program. So the matrix 1, we give int input for I in range n and for j in range p. So here we can say that for I in range n, which is the range for the number of columns of the first matrix, and p is the number of rows of the first matrix. So first we type that. So we then give print matrix 1. We are printing the matrix 1. So in the second here, matrix 1 is equal to int input. In that line, we give the elements. We type in the elements which we want, and then in the next we type in matrix 1. So we are creating the matrix for I in range p, which is the number of rows, and for j in range n, which is the number of columns. We print format matrix 1 ij less than 3. This formatting, this less than 3 is the spacing between elements, and the end that function is to keep the control in that line and not to jump into the next line, and then we print. So when we print here, suppose we give the elements 1, 2, 3, 4, 5, 6, and so the elements which we type in will be created in the p by n format. So similarly, for the next matrix, matrix 2, we type print, enter the elements for the second matrix, which will be shown in the output, and then we give matrix 2 is equal to int input for I in range q for j in range n, which is the nested method, and then we have print matrix 1. I'm sorry, here it is print matrix 2. I'm sorry, that's a typing error. Okay, and then we have for I in range n, the n is the number of rows of the second matrix, and q is the number of columns of the second matrix. So then we have print format matrix 2 ij, the similar way for the matrix 1 also. So here we will get the second matrix, and then we have to store the multiplication in a result. So we type result is equal to 0. First we create a 0 list, and then we input for I in range q and for j in range p. So this is the order, not format, the order of the resultant matrix, which will be p by q. So if the first matrix is of the order p by n and the second matrix is of the order n by q, we have the resultant matrix as p by q. So we type for I in range p, for j in range q, which is for the columns, and p is for the rows, and for k in range n, which is the number of columns of the first matrix and the number of rows of the second matrix. So we have result ij is equal to result ij plus matrix 1 ik plus matrix 2 ij. So we have, when I and j is equal to 0, we have the first element of the first row of the matrix 1, which is multiplied by this first element of the second matrix first column, and then it is stored in the result. And then we print result is for I in range p and for j in range q, print result ij as n 3 formatting, and then we get the multiplied result. So now we move on to finding the transpose of the matrix A. So here, I'm sorry, the first line is slightly shifted to the right. That is a matrix, in fact, I'm sorry. So the first matrix A, is given by 1567, which is the first row, 7951, which is the second row, and 3548, which is the third row. The first row is slightly shifted 2 spaces. I'm sorry for that. So the transpose of the matrix is that the rows and columns are interchanged. The rows becomes the columns, and the columns becomes the rows. So suppose the matrix. So here we have the matrix A, which is a 3 by 4 matrix. We have 3 rows and 4 columns. So when we find the transpose of this matrix, the 3 by 4 is reversed into 4 by 3. So we have 4 rows here, 173, which was the first column, which is turned into the first row, and we have 595, which was the first column of the first matrix, which is transposed into the second row, and similarly 654, which was the first column of the first matrix. Here it is the third row. Okay, third column. I'm sorry. And so all the rows and columns are shifted during the transpose of a matrix. Okay, so now we move on to the program for this. It is fairly simple. So we have p is equal to int input the number of rows. Similarly, we input the rows and columns as we did in the previous programs. P is equal to the number of rows, q is equal to the number of columns, and then we print enter the elements for matrix 1. Okay, so we entered the number of rows and columns, and now we enter the matrix. Okay, so matrix 1 is equal to int input for I in range q and j, q for ij in range p, similar to the first matrix, and then we have for I in range p is equal to for j in range q, print format matrix. So the first matrix, so we print the matrix. Okay, so here it is not necessary for you to type matrix 1, as there is only one matrix which we are supplying. Okay, so after this, the nested loop method, we enter all the matrix elements, and then we find out the result. The result is nothing but the reverse arrangement of the first matrix, so the transpose. So we have result is equal to 0 input. We first enter a 0 list for I in range p and for j in range q. For I in range q, so it is reversed. For I range q, we have and for j in range p, result ij is equal to matrix ji. See here the elements are reversed. the result ij is matrix ji. Matrix ij is transpose a matrix ji. So now we have to print this. So for that we type print result for I in range q, for j in range p, and then we print format result ij. Here result ij is matrix ji here. So we get the transpose of the matrix. And for the final operation, we have the trace of the matrix. I'm sorry, here it is also shifted. I'm sorry for that. For the first row is shifted. Okay, so the matrix A 1 5 2 3, first row, 2 4 5 3, which is the second row, and 1 2 0 5, which is the third row, and 8 1 2 1, which is the fourth row. So the trace of an element, we can only find the trace of a matrix if the matrix is a square matrix. If the number of rows and columns are equal. So we can't find a trace of a matrix for like a 2 by 2 no 2 by 3 matrix or 3 by 4 matrix. It needs to have same number of rows and columns, n by n matrix. So the trace of matrix is nothing but the sum of the diagonal of the matrix. So here we find the diagonal. So here we find 1 4 0 1 is the diagonals of this matrix, and when we add these matrix we get the number 6. Okay, now let's move on to the program of this. And here we have the program. Here first we type m by n, we enter the order of the matrix. Okay, so m is the number of rows of the matrix, n is the number of columns of the matrix. So if m equal to n, only if m equal to n, that is only if the matrix is a square matrix, we can find the trace of the matrix. Else we see that else we type print not a square matrix. Okay, so first m is equal to n, so a we're typing in the elements. A is equal to, we enter a null element first. A is equal to that null square bracket. So then we print the elements. Print enter %d, which is given by elements one by one row wise. So when we type in the elements, it is then given as row wise. So here %d means the order of the matrix which we are giving in the first command, the first line. See. Okay, so for I in range n, the n is the order of the matrix we have. Okay, so here we are typing in the number of rows and columns for j in range n, which is nothing but the rows, the elements. So b dot append input. So it appends the elements which we have typed in for a and b to the null matrix, to the null list. Okay, so the matrix is then formed in these steps for range n, for j in range n. Okay, then we have to find the trace of the element, which is given by s is equal to 0. First we initialize it as 0, and then we find for I in range n, which is the order of the matrix, and for j in range n. So if I is equal to j, so we know that it is a square matrix, so we are adding the diagonal elements. So the diagonal elements I and j are equal. That means the first element of the diagonal is the first element, that is the row 1 and column 1, I one by one. So the next is 2 by 2, which is the second row, second column, and then we have 3 by 3, third row, third column, and 4 by 4, fourth row and fourth column. So s is equal to aij, or this operation only happens if I is equal to j. So we add, the sum is stored in s, which is then stored in s. Then we print the trace of the above matrix is s. So during the first we have s is equal to s plus aij. So suppose in the first we have 0, I is equal to 0 and j is equal to 0. So the first elements, okay, I is equal to 1 and j is equal to 1. So the first element is then added to the second element. So the first element becomes s here. So the second element becomes I is equal to 2 and j is equal to 2, which will be added to the s, which is the previous one. The previous one for I is equal to 1 and j is equal to 1, and that is stored in s, which this looping happens after the order is completed and becomes the number of order which we have supplied. For if it is a 3 by 3, n is 3, 4 by 4, n is 4. And then we print trace of the above matrix S. Else print not a square matrix. This else is for this if function, if m equal to n. Okay, so this is programs for the following, for the matrix addition, multiplication, transpose, and trace. Thank you for watching.